This video will be continuing the tips and revision of probability, and we'll be looking at the distributions that we've covered throughout the course. So binomial distribution. So this is an important distribution. So make sure you can identify the distribution, i.e. like know its characteristics, know it has two outcomes, be able to tell if it is a binomial, and if it is, then you can use the particular formulas in calculating the different probabilities. Know the formula. So the probability of x equals NCX. Important thing to remember is that x and n minus x must sum to n, which is the number of trials. For the binomial distribution, the order does not matter. If it does, then you cannot use a binomial distribution, and you've had to use the previous methods we've looked at. And just to test yourself, can you tell me when, so what conditions of the binomial, so let's say n and p, the number of trials, p, that sort of, when is a binomial distribution positively skewed? So firstly, do you know what positively skewed means? Can you graph it? And then what type of binomial distribution would be positively skewed? So always state units. This is a really important one, an easy one to forget. So no matter if it's a worded question, you always have to state the units at the end of your answer, and even for the standard deviation. So if the units we're talking about, let's say Mars bars for some reason, we're at a milk bar, then the standard deviation of Mars bar sold may be 3, but then you also have to say the standard deviation is equal to 3 Mars bars. So even for spread, you must put units. Markov chains. So Markov chains are important as well, like the binomial distribution. So make sure you can understand and identify them. Now you use transition matrices typically when you're looking for the final outcome. So if you remember, you have sort of a tree diagram and you only care about the final outcome on a particular, the end. So example, the question could be calculate the probability of Wednesday. So a specific day, like a final outcome, rather than looking at a spread of days. And transition matrices are often the easiest when looking for that. Otherwise, you have to use a tree diagram. Now, you also need to be able to work out what the steady state is. So there's a quick way to find the steady state, which I'll show here. However, if you're not too comfortable with the steady state, look back at it as it's important. And this quick way is good in regards to it's quick. However, it's only used for some of the time, so you must understand sort of the other ways as well. So if you want to find the steady state for the probability for success, and this is probability, so not expected number, then you can set up the transition matrix here. Then with success, failure, success, failure, and then whatever you let success is, that refers to that number there. And then you get B, and you put it B on B plus C, and C is there. So steady state probability for success is B plus C. And if you want to look at some examples, you'll see how this actually works and what happens if you increase B. What does increasing B mean with regards to success? And if you increase B, what happens to the steady state? So continuous distributions. So continuous distributions for continuous variables. So make sure you understand what continuous variables are and why are they different to discrete. Well, that's because it's like measured on a continuum rather than discrete values. And you can't find the probability of an exact value for continuous, but rather you have to look for an interval. Now, you have to be careful when you're looking at hybrid functions with multiple functions. So that's a bad terminology, but what I mean by that is you have a hybrid function in which you have more than just, let's say, 2. You have like 3 different, or 3 or 4 different functions. So you have like x on 40, 2x minus 3, ... some other ones, all defined with different x values in different domains. And you have to be careful with that because when you're calculating different values, you have to be mindful about which function you're looking at. And you can't just assume that each function will be 50%. One of the functions may only encompass, let's say, 2% of the data, the next one 53%, next one like 24%. So you do have to be mindful when calculating the mean and values like that you have to recognize that there are different functions. Some of the formulas of the mean is equal to e to x is equal to BA. So remember, if it's BA is just the domain. However, if it's infinity to negative infinity, this is just replaced by infinity and negative infinity. The mode is the top point. So if you have a graph, whenever the top point is, typically an end point or a turning point if it's quadratic, that is the mode. The median, you can calculate it by getting the probability of x is greater than m is equal to 0.5, and then you solve for m. And the m, whatever the value of m is the median. Now, what about variance? To calculate variance, there are two different ways. So firstly, you can do it like this, where you have BA, so that's a domain, x minus the mean, squared, times fx. So whatever the formula is, so that's the formula. So that's only for some specific cases, however it's a useful formula to know. Or you can look at the variance is equal to e to the brackets x squared, close brackets, minus brackets e, the mean, and then squared. So both ways you have to find the mean. So you can think about that as here as the mean. Then here, this term here is the mean squared. But this isn't the mean squared. What this is equal to BA x squared times fx dx. And that comes from the fact that ex is equal to BAX times fx dx, but now we're looking for x squared, and so hence where this squared term comes in. So converting from the standard normal distribution to a standard normal distribution. So you do have to know this. So this is the normal distribution. And it's important that it is normal distribution. You can't just find any distribution. It first has to be normal. You convert it to the standard one. So the standard, if you remember, has the mean equal to 0 and the standard deviation equal to 1. And it's a very easy, not easy, it's a very useful distribution, the standard normal one, which is a bell curve symmetrical shape, and you can find probabilities from it. So to find a particular z value, or otherwise known as a z-score, you equal it to the x value minus the mean of x, and then divided by the standard deviation of x. So lastly, as Obi-Wan says, use the calculator, Luke. And this may seem a bit obvious using the calculator. However, for probability, it's really important. The calculator has lots of functions, and you should know basically how to use them all for probability, such as binomial CDF, inverse normal CDF. So make sure you do know how to calculate them all. For one test I had to do for probability once, I spent about 20 minutes trying to finish one question, like spent a whole page working on it. It was a 3-mark question, and that's because I just didn't realize you could do it on the calculator, and I was trying to do it by hand, and yeah, it wasn't nice. So with probability, make sure you can use the calculator, know its different functions, and for the tech active part of the exam, the probability will become a lot easier. You just then identify what type of distribution it is, know the formula, then you just use a calculator and it does all the hard work for you.